Before starting on number 28, I want to mention that when I'm doing these videos for this practice for the test, I'm moving through the problems at a fairly brisk pace. If you want a more detailed and patient explanation, please refer to any of these videos that I already have posted on YouTube. Review of greatest common factor, that's factoring out the greatest common factor. Also factoring trinomials. And for example of factoring trinomials with leading coefficient other than 1, or something in front of your x squared. Any of the videos that are from 11.4 show, well, almost all of them, show both methods, factor by grouping as well as the box method. Okay? And the other thing I need to mention is that I will be referring to these rules as I proceed, but obviously there's not really room to keep putting them on the screen. But if you don't have these handy, you might want to jot this down and have them handy, because I will refer to number 1, number 2, number 3, etc. Okay? And let's zoom in a little bit and get started. We'll take a look at number 28. And this might look a little confusing to you. I don't know if you've seen a problem like this. Basically what they've done is, when you're trying to factor a polynomial, in this case a trinomial, you're trying to get your answer into something times something. And all they've done here is they said, well, one of these two sets of parentheses is 3x minus 4, and you have to figure out the other set of parentheses. If you tend to try like a guess and check method, or you want to just kind of play with the numbers a little bit, you might be able to just figure out through trial and error what goes in this second set of parentheses. But if not, simply proceed as you would as if that wasn't there at all. Okay? So I would say, proceeding down our list, is there a GCF? No, 17 is a prime. Then if there's something in front of x squared, you can use the box method or factor by grouping. I think I tend to prefer the box, so that's what I'll do. Multiply first times last, and that gives you 6 times 12 would be 72. You list all your factors, 1 and 72, 2 and 36, 3 definitely goes in there 24 times. 4 goes in because that's even, so 4 and half of 36 is 18. 5 won't work. 6, yeah, because twice 3 is 6. Looks like I'm going to have to back out a little bit here. There we go. Alright, so anyway, 5 didn't work. 6 goes in 12 times. 7 won't work, but 8 does. 4 goes in, so if you double 4 you get 8, and if you cut 18 in half you get 9. Alright, so I'm looking for a sum of negative 17. None of these will get me there except negative 8 and negative 9. Okay? And for the box method, once you find these numbers, you're ready to use the box. I can't just plug in an 8 and a 9 here, because notice if I had negative 8, negative 9, that would give me a a positive 72 on my last term, and that is certainly not what I'm after. Okay, so using the box method, nice big box here. Whoops, looking at the screen instead of what I'm doing. Guess I'll slide it over a little bit. There we go. So the first term goes in the first box. The last term goes in the last box. And then these two boxes, that's why you did all this work, to figure out what goes in those two boxes. Okay? So we have negative 8 and a negative 9. And you have to remember to put in whatever variable it is you're working with. This was 6x squared times 12, so that was really 72x squared, which means there's always x next to each term. It's just too much trouble to write that all the time. So just remember to plug it in those boxes. And now you're looking for the GCF. Okay? So going straight up, 3, and if the negative's almost out, I pull it out. So negative 3. Coming up here, I can get a 2x. Coming across, 3x. And coming across here, negative is almost out, so it's coming out negative 4. All right. So notice they already gave us this one, 3x minus 4. So all we're going to need is this 2x minus 3. All right. So that's basically what you would be putting right here. For the answer, you would just put 2x minus 3. Okay. Again, because they already gave you the first set of parentheses. All right, so that's 28, and now we'll take a look at 29. And we're going to factor completely. Again, I'm going to move at a fairly brisk pace through a lot of these. There are more detailed explanations of how to solve them already posted in other videos. Okay, on this one, there's no GCF, and that there's something in front of x squared, so I would multiply 8 times 75, and that would give me 600. And then I would list all the factors of 600. That's rather large. That method will work, so I think I'll approach it. I'm going to encourage you to find some shortcuts when the numbers are this large. And I'll talk about this in two different ways. One is if I multiply 8 times 75, that gives me 600. And I'm going to be looking for a difference of 1. Well, difference of negative 1 actually. So if I start off with my usual practice of 1 times 600, that's a difference of 599. 2 times 300, that's a difference of 298. You can see I'm still a long ways off. So what I'm going to try to do is hurry up down this list. And some of this you can just do guess and check. I'm going to show you a more systematic way to go about it in a second. But if you notice, 2 times 3 is 6. So 20 times 30 would give me 600, but that's still a difference of 10. So I got to make this one a little bigger. And if you go to 24 times 25, there's a difference of 1, and that would give you 24 times 25 is 600. So these two values would go in the box in those two corners. But there's actually a different way. It's a little more sophisticated. And see if you can pick up on this. When I multiply 8 times 75, I get 600. If I had the prime factorization of 600, each of those numbers would have to get used up for every one of these. So the prime factorization of 8 is 2 times 2 times 2. Oops, looks like I'm off my screen here. And the prime factorization of 75 is 3 times 5 times 5. Okay, I just listed the prime factorization of each term. If I multiply these and these, I will get 600. That's just the nature of numbers, and that's why we like prime factorization so much. It shows you what that thing is made of. Okay? So anywhere along here that I grab numbers, let's check this out just to show you it works. 20 times 30, okay? I can make a 20 out of this combo. I could say 2 times 2 is 4 times 5. That would give me a 20. And then what would be left? 2 times 3 would be 6. And then the only thing left here is a 5. That would be a 30. So here's my 20 and 30. So every time you choose a pair of factors, you have to use up all the primes. So based on that logic, I'm going to look for the combination that'll leave me with a difference of 1. Alright, so let's kind of refer to that method here for a moment. By the way, there is at least one other video describing how to work with large, very large numbers. Alright, so I said the 8 was 2 times 2 times 2, and the 75 is 3 times 5 times 5. Alright, so I want some combination that'll give me simply a difference of 1. So this is the 8. It's not going to be 8. If I include the 3 here, if I try that, 2 times 2 is 4, times 2 is 8, times 3, that would be 24. And then 5 times 5, that would be 25. It's a difference of 1, and I know that if I multiply all these together, I'll get the 600 that I'm looking for. Okay, so there are other ways to come about the 2 terms you need to go in the box. I don't usually describe it because it's a little more complicated, but for very large numbers it is helpful to have another strategy. Okay, the first term goes in the first box, 8x squared. The last term goes in the last box. I don't really care about the sign down here. And these 2 terms go in these 2 boxes. So we've got a 24, and you have to remember to put an x in there, a 25, and you have to remember to put an x. And now you just factor out the GCF. Going straight up, we can get a 25 out. Okay. Going straight up, we can get an 8x. Going across, for the 8 and the 25, a 1 is the only common factor, but we can get an x out of each box. And here, 3 goes into that, 3 goes into that, so it looks like 3. I got a little problem with my signs here, don't I? So let's see what I've overlooked. I want a difference of -1, so it must be a -25 and a +24. That means this was supposed to be negative, and if the negative's almost out, I pull that out. Okay? So the factored form of this trinomial is 8x minus 25 and x plus 3. Okay? And again, to reiterate, if you just simply multiply 8 times 75, that'll give you 600. If you list all the factors of 600, you'll end up with a 24 and a 25. So there's other ways to get there. I just tried to shorten it a little bit. Okay, so there's 29. We'll take a look at 32. First, you look for your GCF. There is no GCF. There's something in front of your first term, so you multiply 9 times 4, and that gives you 36. And then you list all the factors. 1 and 36, 2 and 18, 3 and 12, 4 and 9. 5 won't work, but 6 certainly does. Okay, and then you refer back to here. I'm looking for, this tells me it's a difference because this tells me the signs are different. To get a negative, it had to be positive times negative. So when I get around to adding and subtracting, I'll be subtracting. So I want a difference of -9. That won't, this. If I had a -12, +3, that would give me a difference of -9. Okay? So I'm ready for the box now. Over here. And I'll move this over a little. There we go. So the first term goes in the first box. Last term goes in the last box. And these other two boxes, that's why you did all this work, to figure out that you've got a positive 3 and a negative 12. Negative 12. And this next part's maybe a little bit tricky. When you multiplied 9 times negative 4, you really multiplied 9a squared times negative 4b squared. So there was really an a squared, b squared sitting up here, and it was negative. So it's really an ab next to each term. It's just way too much trouble to keep writing it. So you'll have to remember to put AB in each box. All right, and now we're ready to look for that GCF and get on with our work. So going straight up, I can get a 4b out of each term, and the negative's almost out, so negative 4b. Okay. Going straight up here, I can get a 3a out of each term. All right, coming across, I can get a 3a out of each term. And going across, I can get out simply a b. Okay, so the factored form. Of this trinomial is 3a minus 4b and 3a plus b. And the next one we're going to take a look at is number 34. GCF, no. Something, you have 2 terms, no. 3 terms, yes. And there's something in front of the first term. So you multiply 5 times your negative 24, and that's going to give you, I don't usually bother with the sign at this point. So 5 times 24 would be 120. And again, you could get fancy and just look at the prime factorization of each one. You'll be looking for a difference of positive 7 within the products that you can arrange, but I'll just stick with listing the factors here for 120. Okay, so it'd be 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24. Well, that's how we got there, right? 5 times 24, 6 times 20, 7 won't work, 8 times 15. Notice there's our difference of positive 7. I'll just finish it out though. 9 will go in there. No, it won't. 90, nope, 9 won't go. 10 goes, obviously. 10 times 12, and here's all the factors of 120. So again, no matter which one I choose, I'll get a 120. The reason I list them all is so I can find out which pair gives me a difference of positive 7. If I have positive 15 and negative 8, I'll get a difference of positive 7. Okay, so now I just write the box. First term goes in the first box. Last term goes in the last box. And we did all this work to figure out what goes in the other 2 boxes. And we've got negative 8, positive 15. And again, usually I'm saying, oh, you just plug in an x and an x, but this is a little bit different. And you just have to develop an eye for it. This is x to the 4th, which is, you haven't encountered many of these. So really what I did is I multiplied 5x to the 4th times negative 24, and that gave me a negative 120x to the 4th. So that means each of these was an x squared and an x squared, because if I multiply them I have to get this, right? And in fact one of them was negative and one of them was positive. I think you can see why I don't keep writing all this. So the long and short of this is there's an x squared there and an x squared there, okay? Because if I multiply these I have to get that. So basically you just have to understand it and know to put in an x squared and an x squared. Okay? Okay, so the last step we have to do here is look for the GCF going straight up, then straight across, and straight across. Okay? Looking straight up here, we could get 3 would be the GCF. Coming straight up here, we could get an x squared out of each one. And then going straight across, we could get a 5x squared out of each box. And then finally down here we could get an 8 out of each one, and the negative's almost out, so it's coming out. So that would be negative 8. Alright, this gives us the factored form. So you have x squared plus 3 and 5x squared minus 8. Alright, this is the factored form of our original trinomial or polynomial.